seeing the screen? You should be seeing a simulation there. You're seeing it? Anjali, Diego, you're seeing this simulation? All right, ready? So watch this here. So we want to understand the concept of pressure, right? Oh, online now we try that. Never seen that thing. Online. Anybody? Very good. Oh, Elena, can we seeing this screen online there? She was seeing this. Yeah? Okay, nice. So you want to understand the concept of pressure, right? So let's take a look at this fella here. This fella here is 100 grams. Look at the amount of pressure he added, right? Look how far he went to. Right? And I'm seeing the 1 to 2, right? He went in about 20 millimeters, right? Look at this next guy here, Krista. Look at this next guy here. Also 100 grams, but this guy a little bit wider. You're seeing that? He went in, boom, 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 10 millimeters. You're seeing that? So who went in further so far? Slim guy, right? Let's take a look at, okay now, forget him. Let's focus on these two. Right? So my question is, who is exerting a greater pressure? Slim guy or wide guy? Slim guy, right? Slim guy exerting a greater pressure. Why? Right? So Sarah said that the surface area here is smaller. You're saying that? So if your surface area is smaller, small pressure. You're saying that? So how are they related? How is pressure? Can I write here? So how is pressure? How is pressure and surface area related? What's the word? I'm giving you no hints. Two very important words in physics. Something and something. Huh? No, no letters. How is pressure and area related? Two words, opposite of each other. Okay, beginning with D and beginning with I. Directly and inversely. Okay, or indirectly. So how is pressure and area related? Directly or inversely? Listen again. The pressure is larger when the area is smaller. Pressure is smaller when the area is larger. How are they related? Inversely, right? So they are inversely related. If I had no mass, would there be a pressure? If I had no mass, would there be a pressure? No. So it means that pressure has to do with mass, right? What do you expect? A bigger, let's not guess as yet. Let us experiment. Let's take the 50 kilograms and bring it here. It went in about 10 millimeters. What does that say? The bigger the mass, bigger the pressure? Yes. So it means that pressure is directly related to, I'm not using mass, because mass is not a force. What is the force? If object has a weight. Okay, I'll tell you the answer. Right? The weight is the force, right? So here's what it says. It says that the pressure is inversely related to area and directly related to pressure. That's the force. So the formula for pressure is force over area. Okay? So that is the first relationship that I want you to understand about pressure on a solid. Right? If I wanted to make the pressure larger, all I have to do is make the area smaller. That's okay? Anybody can tell me like a real life example where we use this?
High heels.
High heels. Right? High heels. If you want to walk on the sand, would you use high heels? No. Bad idea. Right? If you want to walk in snow, what you can do? You want to walk in snow and you don't want to foot to keep going down in the snow all the time. What can you do? Do you want a large pressure or a small pressure? Small, right? What you can do? Think of if you ever see skiing or if you ever see snowboarding, what you do? Something with a large surface area. You gotta ever watch great guy or something when he uses big snowshoes to walk, right? So if you increase the surface area, pressure is smaller and it allows you to walk like on snow and thing, right? If the pressure is too large, it will sink. Everybody okay with that? Right? So this introduces pressure on a solid. Right? And the formula, force over area. Are you okay with that? Let's check out pressure in a liquid. Online, you all did. Oh. I don't know how people like online teaching. I do not like that. Not tell you paying attention. Hold on, I want to switch. Right, let's take a look at pressure in a liquid now. While you're waiting, think about if you go and swim in a pool, right? And you go all the way to the bottom. Think of where it hurts the most, at the top of the pool or at the bottom. Right? And then we have to know why. Why does it hurt so much at the bottom? Hold on, I just want to get a new simulation. All right, let's check out this one here. That's solid, and the one solid. I want liquid. Hold on earlier. And then get back to one more thing. Been how long to load? See the spring model. Right, but this is solid again, right? But let's see if they have liquid here. Right, these are the two sides that are normally used in simulation. PHAT or oh no, that's not it for sure. Hold on, I'm gonna see if we have. You all may have seen it already where they have 4 holes in a container. Just hydraulic pressure. Alright, and I've seen it, right? Look at this diagram here. Right, so remember we were talking about pool, right? So if you jump in a pool, where would you feel it? Where would you feel the pressure the greatest? At the top or at the bottom of the pool? Bottom, right? So if you look here, there's an example here. I lose the picture. Right, watch this here. So if I were to take if I were to take a, I'm gonna zoom up a little more so you can see. Alright, anyway. So if I take a container and I fill the container with water, right? Just identify that the lower we go, the greater the pressure. Y'all okay with that? The lower we go into the liquid, the greater the pressure, right? So if I made 3 holes, 1, 2, 3 holes here. Y'all seen that? If I make 3 holes in the bottle, you will recognize that the water, the lowest point was put out the furthest. Middle, in between, highest, right? At the highest point, it was put out the lowest. The reason this happens is that the lower we go, the greater the pressure. Everybody okay with that? Nice simple example, right? So what is pressure in a liquid dependent on? Right? Pressure in a liquid is dependent on, we said the lower you go, the greater the pressure, right? So it's dependent on depth. Let's call that H. What else? You all think the type of liquid makes a difference? Yes. So it's dependent on the density of the liquid. And one thing you might see, but gravity is affected by gravity. So these are the 3 things that affect pressure in a liquid. Everybody okay with that? So these are the 2 concepts that we're going to look at today. Pressure in a solid and pressure in a liquid. Everybody okay with that? So head of pressure, head of hydrostatics, subheading pressure. All right, so let's take a look at pressure. Right, so as I showed you before, we have pressure in a solid and we have pressure in a liquid. Right? A small example here, if I give you an object, it's experiencing it is exerting a force, and here there's also a area. Right? So we learned that pressure on a solid is dependent on the force acting per unit area. Right? So you could put this in words, right? Right? Pressure is force acting. Force acting per unit area. Force acting per unit area. Right? And the SI unit is pascals. Right? But we also need to know 2 other units. Anybody can tell me what's the next unit? Based on the formulas that we have here. What will be the next unit for pressure? Force is in what? Newtons. Area is in meter squared, right? So our next formula could be Newton per meter squared. And you have one more. See if we can figure out the last one. You must always have, well, in these cases, you have 3 formulas. Sorry, 3 SI units. Can't figure it out now. You can pick out the last thing. Okay. Okay, one person close there. We gonna do it as well. Right, but you can get it here. Right? Remember, you remember Newton? Newton's is force, right? So you might, well, from what I see in there, you do remember that F is equal to ma. I gave you this formula. M is kg, A is ms minus 2. Right? So if you take n, which is this, and multiply it by m to the minus 2, your formula becomes kg, same base, add the powers, s to the minus 2. So your answer is kg m minus 1 s to the minus 2. Okay, so these are 1, 2, 3 units to represent pressure. All right. So you have to remember all these up. Again, I'll test actually on every single formula in my math. Right? Gotta know that. Okay, so these are the things that we need to know about pressure on a solid, right? Pressure on a liquid now. Same definition, but as I showed you there, pressure is dependent on density, gravity, and depth. Right? Rho is density. Right? I'm writing the unit here in case you forget, kgm to the minus 3. G is gravity. And E is depth. Right? So pressure in a liquid is dependent on that, and we can see it here. If I fill a container and have 3 holes in the container, we saw that the water will go out the furthest and the lowest, middle here, least here. Okay? Right, so note here, pressure increases with depth. Right, Paulia? See how I showed you this version here? You could also get it here. Right? If you multiply the unit for this by this, you'll also get the same thing here. Okay? So that's the next way to check and see if this is correct. This one here, I'm making 3 holes at the same depth. Let's do me a favor now. Draw and see what the liquid. Draw how you think the liquid will come out. Right? When I draw a diagram, draw the 3 holes at the same depth. And tell me what you think about that. right? What will happen? What will happen, Crystal? What do you think will happen? 3 holes at the same depth. What will happen? Evenly, right? Because pressure at the same depth is equal. Okay? Pressure at the same depth is equal. So when the pressure comes, when the water squirts out here, it will be equal. Right? They all will be the same horizontal line, right? My diagram not so hot here, but right? It will be the same distance away, right? It will be the same distance away. Okay? So what are the 3 things affecting pressure in a liquid? Density, gravity by depth. Right? Lower we go, greater pressure, same horizontal depth, pressure is equal. And a solid is force per unit area. That's okay? Presley? That's okay? Sure. You're smiling there. All right, let's take a look at let us take a look at a question. Let's try a little question. Good job, Matthias. Hold on, that's big man. Oh, yeah, I does it best I could do there, but I think we could check it topic by topic. I'll tell you what page, right? Right? If you check it topic by topic, it should be page it's missing a little piece, but page 69. If you check page 69 on the document, and you talk about topic, you'll see this one here. And missing the first part though. Do that please. If you can see. Am I working? You have my number? Somebody can share it in that. Is that it? Do that please, or get disconnected. I think it's the Wi-Fi, come on. Page 69. You do have this first part, right? It starts with the diagram. Check on page 69, 70 around it. Okay, that's it. Right? Answer this first and then go to the diagram. right? Grinding units, divide that. Right? Kita kan close to that. Done with that. Right, yes, I can put more volume on the next part. Right.
Oh.
Right, I just need the first part, right?
You're gonna talk about.
Right, so volume is what? What's the SI unit for volume? Meter cube, nice. What's the SI unit that is kgm to the minus 3? Density, very good. The third one is pressure, and newtons is what? Force. Pressure is what? You have two options, pascals. They said derived units, right? So it could be pascals, it could be Newton per meter square, or kilograms per meter per second. That's okay? So you have all the options there that you could write, right? Do the calculations now, should be almost done. I have to find the pressure, right? Find the density. Should remember your formula density is what? Mass over volume, right? Density is mass over volume. Then define pressure, look at it here. And then find the formula. Sorry, then do the calculation. Yes. Ready? I online, you can message the answer or two. Answer, you done? Yeah, yeah, part 3 as well. 1 to 1. Perfect. You can take it off. Take it off. That is what you I can lower it and see, but I don't think that'll do it, huh? And I can lower fan speed. Give me a minute again. This one? Yeah. What are you gonna do? So they give you everything, they give you the map, so you can find a way. Which one? Or which one? Oh, yeah. No, well, you're not using this version because you don't have it depth and it's not in a liquid. You're using this version. Force over area. So you have to find the area in space. And remember, forces mass by gravity and by G. Right? That's why they give it, G. Online message answer for the last part, now, please. Right, let's begin the calculations. First part is to find density. We know that density is mass over volume, which is 20160 all over the volume. Remember, you can't work in centimeters, you have to work in meters, right? So that's 3 by 2 by 1.4. How much is that? 86,000. 185. I can make sure. Right, I have 2,400. Everybody else get up? 2,400. Yeah. Please remember that your values must be in SI units, right? So it must be 1.4, right? Must be in SI units. Right? Pressure, we know what pressure is. Pressure is force acting per unit area. Force acting per unit area. Then they want us to find pressure, right? I'm writing up here, right? We know that pressure is equal to force over area. and the force is mass by gravity over the area. So I have the mass, which is 20160 by gravity, which is 10, all over the area, 1.4 by 2. Right? So the answer I got, hold on. I got 72,000. Anybody got that? Yeah? Check it back and see 20160 by 10 all over 2 by 1.4. Weight over area. Y'all got that? Right, so please remember that the force exerted by any solid will be its weight, right? So the force exerted by any solid is its weight. Everybody okay with that? Online, everybody okay with that? Right. So we have an application to learn now. Right? Here's an application of the good concepts that we learned. So if you look at this here, you will recognize that, look at this force, right? Well, there are no values, but this small force has the ability of lifting something that requires a larger force. This is a simple hydraulic lift, right? And you all may have seen it like in, if you ever went to like those mechanic places and they're able to take this, apply this small force and allow a large object to be lifted. That's the same thing here, right? So we need to figure out, okay, how does this work? How does this small force be able to lift a large force? All right. So the principle behind it is simple, right? That's an application. Watch this here, right? And let's change the diagram slightly, because I want you to see one of the principles. Right. So if you look here, we have two pistons. Under the piston is an incompressible liquid. What that means is that no matter how you try to squeeze that liquid, it will not change its volume. It will stay the same. Okay? So you cannot compress that liquid. So if you push on one side, the next side will go up. All right? So here's how it works. First thing I want to identify is that these two are the same level initially. Right? Initially, these two are the same level. All right? When I apply a force here, let's call that force F1. Remember that piston has an area? Yeah? That piston has an area. It's a small area. So what that means is that at this piston, there is a pressure being exerted. And the pressure is F1 divided by area 1. Everybody okay with that? Is that okay with that? So on the piston 1, there is a pressure, F1 and A1. But because they are the same level, what did we learn about pressure at the same level? It's equal. So it means that we have the same pressure here. Let's call that pressure P1. Right? So the pressure P1 is equal to the new pressure being acted on him. Let's call that P2. And if P2, if we have a new pressure, then since we already have area, we can easily find that new force which is larger. All right? That makes probably absolutely no sense. But I have no numbers in it, right? So I'm gonna put some numbers and I'm gonna show you how this small force can allow it to lift a large force. You okay with that? Right? Do I make it draw it? Yeah. Draw the one in red. Head up hydraulic lift. Draw the one in red. On the board, I am going to give you some numbers. So it will make a lot of sense now, right? Hopefully. Copy it down. The one in red, eh? Don't try to draw the max the answer. Right, draw the one in red if you can see. See, if I think about our big class coming up, I can sit down here, they'll start this up. We'll go, we're not getting harder. Let's not do it too much. Right, and last thing, before you all freeze to death. Right? So I want to show you how it works, right? Oh, wait, coloring guys. Color guys. So watch this here. Watch here for 1 minute, right? So how does this whole thing work? Well, as I said, we need to remember that the pressure here is equal to the pressure here. So I'm going to find P1 first. P1 is force over area. So the pressure is 10 pascals. So what does that say about this pressure here? Same thing, right? Right? So P2 is always 10. It's also 10. And if P2 is 10, can we find F? Yes, we can, right? Remember, pressure is force on area. So force is pressure by area. So the pressure is 10, and the area here is much larger. Area is 100. So the final answer is 1000 Newton. Right? So something with 10 newtons can lift something 100 times its weight. That's okay? So it's showing how a small force can lift something much larger. So important this fluid is. If this fluid leaks out, this doesn't work. All right? Right? Copy that down. right? So this is the concept of the hydraulic lift. I know what the freezing, right? Just one question I'm gonna.
Jog sila. Palagi sila.
Try that fast. Find the pressure exerted by F1 and then find the area to raise the arm. In part two, you're finding the area because it gives you the force. Look at that zoom in on the values, right? Go ahead, do that fast. Find the pressure and then the area. Everything I did on the board except instead of solving for pressure, you're solving for area, right? Oh yeah, we just quick, last one and we're done. 10 to the 5 means what? 10 to the 5 is the same as 1 by 10 to the 5, huh? Right? Same thing, 100,000. Good. We gotta make sure we quick the calculator. Right, and just checking it in part one. Pressure is force over area. So that's 1000 over 0.002. That's how much? 5 what? What's that again? 5,000. 500,000 pascals. Okay. What's the formula to find area? Stay tuned. Help me out now. What's the formula to find area? How do you pronounce the first name? Yeah, I'm gonna get that. I'm gonna get that. Yeah, I'm here. How do you find area? Area is what? Just rearrange this. Pressure is forced by area. Area is what? Force divided by pressure. Right? So the force is 10 to the 5 and the pressure is 500,000. Anybody have an answer? How much you get? 2? Yeah, that sounds like it. 2 meters squared. Right? So that larger area allows you to get that greater force. All right. Next week we do class papers, right? We have one more thing to do.